this. We knew that there is this excess negative charge from a shower that would be happening, and that it's expected to give us coherent radio emission. And because of that, we expect to be able to pick, like, that's how, why we designed the experiment around that. Okay. But I'm trying to find the paper on our Slack work. Scooby-Dooby-Doo, where are you? Are you serious? If I did not reference the Slack paper, then I am confused. That's okay. Whatever. We'll keep going. But there's definitely a paper on that too. Our early work paper, sort of the history of Anita and the history of this whole thing, of this whole thingamawitch. Anyway, we'll keep going. Oh God, this thesis is so long. Who wrote it? Okay. That one's done. Okay. Now we're going to talk about Anita. More specifically. So we just talked about the Ascarian effect. And now, henceforth, we will talk about Anita. My Anita. Me. So we're going to talk about me. Fewer electrons than protons. In the shower, you mean? No, in the shower, it's fewer positrons than electrons, is why we have the charge asymmetry. Because the particle shower had photons, electrons, and positrons, and there are fewer positrons, which is positively charged, than electrons. Positron is simply the antiparticle of electron. So, no. There are fewer positrons than electrons, so you have a negative charge asymmetry. Okay? You have more negative charge. Because the particle shower initially has photons, electrons, and positrons, and as it travels through the ice, if it's making more electrons because of Compton scattering and losing positrons because of annihilation of positrons to make, again, electrons rather than positrons, then it's going to have more negative charge. Okay, so now we'll talk about Anita. Anita is an experiment dedicated to discovering ultra-high energy neutrinos via the Ascarian effect, utilizing the Antarctic ice as the necessary dielectric target medium for neutrino interaction. So the ice is the dielectric target medium as in the stuff that the neutrino will hit. Where Anita's sensitivity lies in the energy scale as compared to other experiments in particle physics and particle astrophysics is presented in that figure I showed you earlier with the big black arrow and all the experiments. A cartoon of an ultra-high energy neutrino coming into the ice and starting a particle shower that leads to Cherenkov radiation emitted coherently and at an angle of around 56 degrees is shown in that cartoon I just showed you. Anita looks for radio Cherenkov signals with an array of radio antennas. The Anita detector is hung from a helium-filled balloon and launched from near McMurdo Station in Antarctica during the austral summer. After it is launched, Anita floats up to an altitude of about 40 kilometers and utilizes the polar vortex to fly in roughly circular orbits over the continent of Antarctica.